this video, we'll focus on practical real-world problems we can solve using differentiation. First, we'll cover distance, speed, and acceleration, and how they relate to each other. Second, we'll look at rate of change, both between 2 points and at a single specific point. Lastly, we'll dive into optimization, which means finding a maximum or a minimum. All right, let's kick off with distance, speed, and acceleration. When we look at distance, speed, velocity, and acceleration, there's a relationship between them. Those of you who took physics at school or are studying it at university will know that if we plot them, a clear connection appears. Without going into unnecessary detail, if there's a graphical relationship among the three, there must also be an algebraic one, and that relationship is differentiation. The key idea is this. If we take a function f of x that represents distance, differentiating gives a new function for speed. Differentiating again gives a function for acceleration. As simple as that. So distance differentiates speed. Speed differentiate acceleration. Let's look at an example. Right, before we dive in, we need a plan of action because it's easy to get lost in these kinds of problems. The easiest way to learn this is to split the questions into 3 groups. Group 1, the function they give you. If they ask anything about distance or sometimes height, you just use the original function they gave you. If they ask about speed, first differentiate the function once and use that new function. If they ask about acceleration, differentiate the original function twice to get a function that represents acceleration. Group 2, rate of change. This means how something changes. We can measure change between 2 specific points, for example, between 3 seconds and 7 seconds. That's an average, so for speed, it would be the average speed between those 2 times. To find it, use the usual slope formula. Another type of rate of change question is instantaneous rate of change. How something is changing at a specific time. They give you just 1 point. What is the rate of change at 9 seconds? Here we can't use the normal slope formula, which needs 2 points. Instead, we differentiate the function and then substitute the given time. A good example is instantaneous speed, speed at a specific moment. Group 3, maximum or minimum. When they ask for a maximum or minimum, we differentiate and set the derivative equal to 0. So that's our plan of action, a kind of cheat sheet for what to use where. This will make a lot more sense once we've done the examples together. Let's dive in. The full video is only available to our awesome ebook course students. In our ebook course, all your videos live in one place, together with the ebook and downloadable cheat sheets. No more 2 a.m. doom scrolling on YouTube before a test. Everything's in one spot to help you succeed at Calculus 1 the first time. Let's be honest, I'm not here to convince you of the beauty of calculus. I'm not a professor who can talk for 3 hours about how elegant differentiation is. This is damage control to get you through Calc 1 so you can move on with your degree and with your life. This is your please don't ever make me redo this class again plan. And it's all at a student-friendly price that costs less than a mid-tier restaurant meal. Not even steakhouse level, more like a fancy burger with just one side. See you inside the ebook course.